This conference will now be recorded.
Welcome to our talk here today about Flash for the Future, about form factors. Thank you for joining me. I'm Ross Denfort at Facebook. With that, how about if we get started talking about form factors? But before we talk about form factors, we should talk about where we've been and where then it makes more sense of where we should go. So let's start with what's the problem with M.2s? Power and thermal does not scale. We're unable to activate all the dies, whether that's TLC, QLC, or SEM, and thus we're performance limited. M.2s do not scale well past 2 terabyte due to the performance and power limitations. There's no standard thermal solution. There's poor serviceability, no hot plug support, and requires costly material choices that don't add value. So then the question is, well, where should we head? So this is where we need to talk about the benefits of E1S. E1S with the same PCB and firmware support a diverse family of thermal options for the market. There's both high density and high performance. If you look at the pictures on the right, you will see how there are high density options. There are 3 of them listed there. And there's also a 25 millimeter high performance option. By having this diverse set of options, you can scale based on your needs for thermal with the same PCB, firmware, and chips. It makes it very convenient. It has hot plug support. It works for both storage and compute in 1U. It supports both Gen 4 and Gen 5 PCIe, and it's fully standardized in SNIA SFF. Now, let's talk about hyperscale's needs to set the backdrop for everything. The IOPS per terabyte need to scale linearly. Thus, when you see this table of capacity of 1 terabyte, you have 1x performance, and 2 terabytes, you have 2x performance, all the way down to 16 terabytes where you have 16x performance. In the data center, we need performance to scale per terabyte linearly. Another critical item to be aware of is low airflow. Low airflow is critical to ensure the data center airflow is sufficient. Facebook's data center requirement is 0.145 CFM per watt for airflow. In addition to that, serviceability matters. It needs to be easy to service the boxes and take care of them in the data center. And most importantly here, the solutions need to scale for the future. Now let's look at some industry trends and the background around that. The first is NAND dies are getting larger. That means the 256 gigabit NAND die and the 512 gigabit NAND die will go away. The consequences of those are when that happens, the 1 and 2 terabyte data center performance grade SSDs will also go away. In addition to that, there's dark flash that cannot be utilized due to changing compute and flash ratios. PCIe Gen 4 and 5 are coming with increased power. Now, let's look at a table of mainstream unthrottled power and capacity trends below here. You see the SSD capacity types of 1, 2, 4, and 8 terabytes TLC down to 16 terabytes TLC. And we talked about how the trend is towards larger drives, and that trend will continue. In addition to that, you see the SSD device power, and you can see how the trend is for higher powered devices. However, if you look at the terabytes per watt, the terabytes per watt is actually decreasing, which is a good thing as it makes things more efficient in the data center. So in the future, the data center SSDs capacities will increase, the device power budgets will increase, and the terabyte per watt ratio will decrease, improving the power efficiency in the data center. Now, let's look at a picture of a storage box here. This is Yosemite v3 and 10U, and it's specifically designed to scale for the future. We start on the left, you see the picture of the 25 millimeter E1S latch, allows easy serviceability in the data center for hot swap and pulling drives in and out. You then see a picture of a blade. In the blade, you see 4 25 millimeter E1S drives that can be put into that blade. It has compute in the back and storage in the front of the blade. And then you see a chassis. The chassis here will hold 12 blades in the chassis. Now, if you go to the right side of the chart, you see how we describe the blade will support 4 25 millimeter E1S drives, that's storage and compute, The chassis has 12 blades per chassis. So this results in a highly scalable solution. It'll support 48 25-watt SSDs at low airflow. That's 768 terabytes in 4OU. That's a lot of storage in 4OU. In addition to that, it supports TLC and SCM. Now, let's look at the thermal performance, as we talked about how low airflow is critical for the data center to ensure it doesn't run out of airflow. On the left side, you see a graph. You see power going up on the vertical axis, starting at 5 watts, going to 30 watts. You also see the width needed for E1S from 9.5 millimeters all the way to 25 millimeters. Then you see the trend line in black, where the trend is towards higher power. The black line represents the CFM per watt requirements for the data center. And so those are the thermal requirements that you need to meet. Then you see a light gray band going through the middle of the graph. That shows the thermal limits for M.2. So now that we've looked at, and in addition to that, I should say, then we talked about the power requirements for different capacities of drives from 1 to 16 terabytes, and those are now overlaid on the graph. So now, what can we take away from this graph? The first is 25 millimeter E1S will scale to meet the power and performance requirements for low airflow and thermal requirements. As you can see in the YV3 box, we can scale from 1 terabyte all the way to 16 terabytes and also put storage class memories in it, and it scales very nicely. The next takeaway here is M.2s will not scale at 4 terabytes or larger. If you look at the 4 terabyte orange arrow, what you see is it's above that gray band. So whether your M.2 is at 8 watts or whether it's at 12 watts, the orange arrow goes past that, and the amount it goes past it represents unrealized performance due to power capping. Thus, 4 terabyte M.2s cannot meet the IOPS per terabyte performance requirements needed in the data center. The next takeaway here is less than 25 millimeters E1S will not scale at low airflow. When you look at this, if you go less than 25 millimeters, it becomes very challenging of what your wish should be. On the low end, we have the 1 and 2 terabyte drives going away, and so those disappear off the curve. On the right side, the question is, how big of drives do you want to support? Is it 16 terabytes? Is it 8 terabytes? Is it 4 terabytes? Based on that, you'll come up with different answers for the width. If you use 25 millimeters width, you'll be able to scale at low airflow from 4 to 8 to 16 terabytes without issues. And with that, let's look at the next slide here showing 25 millimeter E1S drives and how they're here now and they're scaling for the future. And with that, thank you very much. I appreciate your time. And here's a picture of our data center showing lots of hardware, and we're looking forward to deploying more hardware. Thank you very much for your time today. Bye.
Hi, this is Russ Denford at Facebook. I appreciate you taking the time to watch this presentation. And with that, how about if we take a few questions? So I see a few questions here. Let me start with the first. The first is, how do you pull out the E1S drive? When you look at the pictures, you saw a picture of the Facebook latch. There's a handle that flips open on that latch, and that allows you to pull open the drive and pull it out of the box. Let's see here. What other questions do we have here? Next question here is, who makes the 25 millimeter E1S enclosure? The answer to that is the drive vendor. If you look at slide 9 here, you'll see a picture of many drive vendors. I'm not sure this is inclusive of everybody. I'm sure it's not, but here are some drive vendors that you can talk to who have enclosures around their drives. Next question here. I see a question. about SEM support. So I encourage you to go talk to your drive vendors who build SEM drives. Certainly this form factor can support SEM because there are many SEM drives that are NVMe block devices. And this will work very well for those if you want to mix SEM and TLC together. Let's see, what other questions do we have here? New question here. What are my thoughts around the proposed new 15 millimeter versus the 25 millimeter? As you saw, I showed a thermal curve for our Yosemite V3 box, and it showed how we need 25 millimeters to get to 16 terabytes. The 15 millimeter, you can look at the dimensions at the bottom, and based on that, you can determine at what capacities we're unable to scale with the 15 millimeter. Next question here, do we plan to use E1L? Currently, we have no plans around E1L. I see a question here about details on the Yosemite platform. If you go to the OCP server group, you'll see a presentation on Yosemite V3 that was given yesterday. And that's a great presentation I would recommend you looking at. And with that, I appreciate all of you calling in and taking the time to listen to me. And I want to wish everybody the best. Thank you very much and have a great day.